So when you graph sine and cosine, right, we said that both of them alternate between the zero, the minimum, and the maximum, right? So when you're asked to graph a sine or a cosine function, you're going to draw your x-axis. Then you're going to have to label 5 points on the x-axis. You need those 5 points. So the first and the last are the start and end of the period. And then in the middle, in the very middle, you've got the midpoint, and then you've got the quarter point and the 3/4 point. But no matter what function it is that you're graphing, any trig function requires those 5 points on the x-axis. So how many points? 5 points. Now, at those points, one of 3 things can happen. The function could either be 0, right? At how many points is the sine function 0? At how many points is the sine function 0? 3. Or the function can be a maximum or a minimum. For the cosine function, again, we've got our 5 points. All right? At how many of those 5 points is the cosine function equal to 0?
2.
It's 0 at 2 points, right? And then there is a minimum, a maximum, and a maximum, right? So I call those the 5 critical points because, and at those 5 points, again, one of 3 things happen. The function is either 0, a minimum, or a maximum, okay? Now, we're going to use the fact that sine and cosine are 0 at 3 or 2 distinct points if we want to graph the tangent function. How do we define tangent?
Y over x.
It's y over x, right? And if y is sine of x, if y is sine and x is cosine, then if tangent, right, if tangent of theta is y over x, if y is sine and x is cosine, then tangent is sine over cosine. Okay? Now, so now we have a fraction, a rational function. Remember rational functions from chapter 8? You guys, everybody's favorite from chapter 8. So a rational function is something like 3x over x plus 2. When would that function run into a problem? When x equals negative 2. Because when x equals negative 2, what happens to the denominator? The denominator is 0. So remember, the denominator can never equal 0. Now for the tangent function, what's in the denominator? Cosine. So if cosine is ever 0, the tangent function can't work. All right? So let's go back. At how many points was the cosine 0?
3.
Cosine? Cosine is 0 at 2 points. Where is cosine 0? At
quarter.
At pi over 2 and, right. Okay, so the moral of the story is, wherever the cosine is 0, tangent can't work. And cosine is 0, right, on the unit circle. Cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and 9 pi over 2, 11 pi over 2, and so on, right? Or if we're going in the negative direction, cosine is 0 at negative pi over 2, pi over 2, and so on and so forth, okay? So at those points, negative pi over 2 and pi over 2, the tangent can't exist. Now, let's take a look at how tangent looks. Tangents are like vertical branches, let's say, but you see how the same cycle repeats again. So you have 1, 2, 3 branches, and so on and so forth. So again, you've got a periodic function. It's a cycle. And how big is the period of this function? Let's see. It goes from negative 90 to 90. So how much space is in between from negative 90 to 90? 180. So the tangent has a period of pi or 180 degrees. Okay? Mm-hmm. What was the period for the sine and cosine functions? 2 pi. For the tangent, now it's pi. That means, remember how for sine and cosine we had to find 2 pi over b? Now for tangent, we have to do pi over b, or 180 over b. Okay? Any questions? Okay, so 2 things you need to remember. One is the period of the function for the tangent, the period is pi, not 2 pi. The second thing you have to remember is sine and cosine. Sine and cosine. Okay. Sine and cosine start at 0 and go to 2 pi. Tangent starts at negative pi over 2 and goes to pi over 2. All right? So please remember that for the tangent, you don't start at 0. Where do you start? Negative pi over 2. Not 0, okay? All right, now, remember how I said when cosine is 0, the tangent is undefined? At those points, tangent has vertical asymptotes, right? Just like our rational functions at x equals negative 2, this would have a vertical asymptote. Wherever cosine is 0, here there is a vertical asymptote. So to graph a function, you need to figure out the period and you need to figure out where the asymptotes are. So, in order to solve for the asymptotes, this is what you have to do. So you have to take that term, b theta, okay? And we have to bind them between negative pi over 2 and pi over 2, and it gives us our asymptotes. So let's do one here. It says find the periods and asymptotes of each function, then graph. So let's do the period first. The period is going to be pi over the whatever the coefficient is in, not there, sorry. Whatever the coefficient is in front of the theta, which is 1. So the period is just pi. Now for the asymptotes, here's what you have to do every single time. You have to do negative pi over 2, less than, and then less than pi over 2. Right? So you have to always do that, negative pi over 2 to pi over 2. You have to set up an inequality. Then you take that term, all right? So whether it's a single theta, whether it's 3 theta, half a theta, whether it's 2 theta plus 3, whatever it is, you take that term, you put it here, and then you have to solve for theta to be alone. Now in this case, theta already is alone, so where are my asymptotes? These are my asymptotes. So I say x is pi over 2, x is negative pi over 2. Okay, what was your question? Yeah. All right, so now, when we solve that inequality, we get 2 things out of it. One is, these are the asymptotes. It also gives us the start and end point of the cycle, of the period. So first we have negative pi over 2, and then I go 4 units over for pi over 2. Now, can I find the midpoint of those 2? What's the midpoint from negative pi over 2 to positive pi over 2? 0. Can I find the quarter point?
Yeah,
negative pi over 4. And this would be pi over 4. All right? Now, at the start and the end, what we have are asymptotes. Okay? Okay, now here's the deal. At 0, tangent is 0. On the right, at pi over 4, you go up 1. On the left, at negative pi over 4, you go down 1. And that's how it looks.
How do you know you go up one?
Okay, how do you know you go up one? What's tangent of pi over 4? What's tangent of 45? 1, right? So tangent of 45 is equal to 1. What's tangent of negative pi over 4? That's in the 4th quadrant. What's tangent there? Negative 1. All right? So there is not much of a mystery there. Right. Yes. Huh? Right. Still, at the first point, you would go up 1. Always. Okay? Unless there is a negative, in which case there is a reflection on the x-axis, and we'll talk about that. All right, so let's take a look at this one. Now we have 3 tangent 2 theta. All right? So for the period, it's going to be pi over b, and that is b. So that's going to be pi over 2. So it's pi over 2 or 90 degrees for the period. Okay? No, it's the, which one? Now we're going to use that same inequality, negative pi over 2 and pi over 2. What number do we put in there? No, 2 theta. It's all about the 2 theta. The 3 isn't going to do much in this case. So it's the 2 theta. So what do I do to solve for theta now? Divide by 2, divide by 2, divide by 2. So we go from negative pi over 4 to theta to pi over 4. So where are the asymptotes? X equals negative pi over 4, x equals positive pi over 4. Now, if you want to condense that and you want to write x equals plus or minus pi over 4, you're more than welcome to do that. Okay? Or in degrees, this is x equals negative 45 and positive 45. So for this one, let's work in degrees and not in radian. All right, here's my x-axis. We're going to go from negative 45 over 4 spaces to 45. And at those 2 points, I have asymptotes. Same deal all the time. Now, what's the halfway point? What's the midpoint? 0. What's the midpoint between 0 and negative 45? Negative 22.5. Negative 22.5. Oh, positive, sorry. Positive 22.5. All right, so here's what I said before. At 0, tangent is always what? 0. Because tangent of 0 is 0. Now, to the right, remember how we said you had to go up 1? But because of the 3, we have to go up 3. So 1, 2, 3. So that's like a vertical dilation. And then to the right, I'm sorry, to the left, we're going to go down 3.
So is tangent of 22.53?
No. Tangent of 22.5. Okay. What's the equation? It's 3 tangent 2 theta, right? That's y. So y is equal to 3 tangent 2 times 22.5. Right? So that will be 3 tangent, what's 2 times 22.5? 45. Now, this is equal to 3 times, what's tangent of 45? 1. So y is equal to 3. You see it? Okay. And, you know, students usually, like, try to give this, like, a curve, and then it ends up looking like a, I don't know, like some sort of, like, other snake. This is what I usually get from students, because they try to give that curve. Don't exaggerate those curves. There will be some points off, because you're adding, like, extra dimensions there that shouldn't be there. What that vertical dilation does is it takes this graph of the regular tangent, and imagine if you were to, like, tie a string to both ends of this and just pull it up, right? What would you do? You would just straighten out that tangent. You wouldn't add any more curves to the top and the bottom. So just, visualize it that way. All right, let's do one more. So here we have y equals -3 tangent half theta. What is the period going to be? The period is pi over 1/2, which is how much? 2 pi, right? It's 2 pi. 360, right?
Oh.
So, okay. Now, what we're going to do is we're going to solve for the asymptotes. So we're going to go from -pi over 2 to pi over 2. And what do I place in the middle? Half theta. How do I solve for theta? Multiply everything by 2. So I get that I'm going to go from -pi to pi. All right? So here is -pi to pi. What are my asymptotes? X equals plus or minus how much? Pi. Now, how long is the distance from -pi all the way to pi?
360
Or 2 pi. And is that what we got for the period? 2
Yeah.
pi? Okay, so always make sure, this is a way to check your work. Always make sure that that distance, when you count that distance, it's consistent with the value that you got for period. Okay? Does that make sense?
Yeah.
Okay. It's math. I mean, it's got to make sense, right? Okay, so what's the midpoint here? 0. And the quarter points? Pi over 2 and -pi over 2. Okay, here is my asymptote on the left, and here is my asymptote on the right. Okay, what's tangent at 0? 0. Now, yes, it's opposite. Now, to the right, we were going up, right? In this case, we would have to go up 3. But now that there is a negative in front, we're going to go down 3 to the right. And to the left, we're going to go up 3. Okay, so this is called a what?
A reflection.
Around.
The x-axis.
Awesome. You guys are sounding like Algebra 2 students.
Finally.
Okay. Right?
Yeah.
We got sine, cosine, and tangent now. We're cool on how we're graphing this.
Is that it?
This is it. So these are okay. Now it's time for you to reproduce one of these on an assessment, whether it's a quiz, a test, a final, whatever it may be, right? What am I looking for? What am I looking for on a tangent graph? What's one thing I'm looking for? I'm looking for the asymptotes, 2 of them. There must be 2 of them. What else am I looking for? The period is correct. What am I looking for on the graph? Here I want 5 points. I want these 5 points. 1, 2, 3, 4, 5.
You want to start
Okay.
shooting,
I mean, you can start wherever, but I do want 5 points. I want all these labeled, not just the tick marks, but like the actual values of them. And I do want to see these points. Okay? Yes.